All right, page 175, number 13. We've got light bulbs, normal distribution. Standard deviation is 40.6, 10%, lasted longer than 5,130. Find the mean to the nearest hour. All right, so let's spell some of this out. We have a normal distribution. We don't know the mean. We do know the variance is 40.6 squared. If we kind of visualize this, we can see that our point 5,130 is got 90 to the right, 90 to the left and 10% to the right. Well, our tables go to the left, so we're going to use 90%. And now all we have to do is multiply both sides by 40.6. And we get this, and then we're going to subtract 5,130 on both sides, and then divide by -1 on both sides, and we'll find out that our mean is 5,078. And if we want to go to 3 significant figures, then it would be 5,080. Alright, so now let's look at part 2. Part 2 says find the probability that a light bulb fails to last for 5,000 hours. Well, it fails to last for 5,000 hours. That means that X is going to be less than 5,000. So we're going to do the same thing. We're going to standardize it. And now we have the mean. We're going to use the 5,078. And we'll divide by the 40.6 they gave us originally. And we find out that that's going to be -1.9211. Now, when we look at it, that's on the negative side of the normal curve, of course, and our tables don't have that, so we pick its symmetrical brother on the other side, and we're going to do greater than the positive 1.9211. Well, again, our tables don't go to the right, they go to the left, so if we take 1 minus that, we should be in good shape. So anyway, go to the table, 1.9211, 1.92, and then 1. Make sure that you round this. When you get, all you need is 3 decimal places after the decimal point. So round that third number. Anyway, in this case, it's not much of a rounding situation, but I get the probability of 0.9727. If I take 1 minus 0.9727, then I'll end up with 0.0273. All right, let's take a look at part 3. Part 3 says I got 600 of these bulbs, and they want us to use a suitable approximation. They're basically begging us to do a binomial approximation here. We're going to shake this binomial situation and represent it as a normal distribution. All right, so fewer than 65 bulbs. All right, let's spell out our information. And we got 600 trials. Each bulb's a trial. Probability of success is 0.10. So it's a binomial distribution. Either it's working or it's not working. And we write this as a normal distribution. We write the number of trials times probability of success, and we get 60. And then we take that and multiply it times Q, 0.9, and we find out that we got a variance of 54. So now we're trying to find out the probability of V being less than 65. And of course, we have to standardize it, but keep in mind, when we're doing this, we have to get continuity correction. So we're less than 65, and we don't want to include the 65. So if we're going to go less than 65 but not including it, we're going to use 64.5 as our target, and then take that away from the, subtract the mean, 60, and divide by the square root of the variance. And then when we find the probability of that, we'll be in good shape. So all we got to do is clean all this up. We find out we get 0.6123, and we go to the table and look at 0.6123. And we find the probability is 0.7298 or 0.730, 3 significant figures. All right, hope that helped. Thanks for watching.